The addition rule is a probability rule. It's also called the sum rule. And this particular rule states that the probability that one or more mutually exclusive events will occur is going to be equal to the sum of their individual probabilities. So if we look at this a little bit closer, because this is going to be something that's useful when we do look at genetic crosses, notice the word or here. So while the multiplication rule, a lot of times we call it the and rule, this one is what we tend to call the or rule. So when you talk through genetic problems or genetic scenarios, sometimes you'll find yourself saying or, and that would be a good clue that you want to actually use the addition rule. So we're going to have one or more mutually exclusive events. So by mutually exclusive, what this is saying is that both can't occur. So both, if we were talking about two of them, if we had multiple ones, then all of them can't occur. Just one of them is going to occur. And so what we would do is we would figure out the probability of each event. So we would have event A and we'd have the probability of that. And then we would have event B, and maybe we have 3, maybe we have event C as well. So if we wanted to know the probability that event A, B, or C is going to occur, we would figure out the probability of each one of these, and then we would add them together, and then we would get the probability that one will occur. So let's look at an example of where we would use this. So one place where we do see the addition rule used a lot is when we're talking about something happening in different orders. So if there's multiple orders that the event could occur. So suppose we had a question and we wanted to know what is the probability that when we have two children, we will get one boy and one girl. Okay, so this is kind of a common scenario or thing that people wonder. They want to have two children, they want one boy and one girl. Well, notice with this that there are multiple ways that that could happen. Because if we write the ways down here, we could have the boy first, and then we could have the girl second, and that would fulfill this scenario. But then we also have another option. We could have the girl first, and we could have the boy second. And it's not going to happen both ways because we're only having one child. So that's what we're talking about when we talk about mutually exclusive events. So it's the first order, or it's going to be the second order if this is going to happen and we're going to get one boy and one girl. So if we go through and we solve this, what we would do is we would first figure out the probability of this order where we have the boy first and then the girl. So I would look here and I would say, okay, when I have this first child, what is the probability that that child will be a boy? And the probability of that's going to be 1/2. And then the next time, the probability that that child's going to be a girl is going to be 1/2. And since these are independent events, since they are what we would call subsequent offspring, I'm going to use the multiplication rule and I'm going to multiply those together, and I'm going to get an overall probability for this particular order. I could come over here and do the exact same thing for this order. The probability that that first child is going to be a girl is 1/2. And then the probability that when I have my second child, it's going to be a boy is going to be 1/2. So I take that, I multiply them together, and I get 1/4. So it's 1/4 for this order. Well, if we're using the OR rule, which is the addition rule or the adding rule, what we're going to do is we're going to add those two together. So I'm going to take my 1/4 plus 1/4, and when I add those together, I do get an overall probability of 1/2. So what that's telling me is that when I have two children, if I don't really care about the order of the boy and the girl, I have a 1/2 probability or a 50% probability that I'm going to get one that's a boy and one that's a girl. So that's a non-genetic scenario. So if we take this and we look at a genetic scenario, we could say, what is the probability that when we have two offspring, that one will look dominant and one will look recessive. So very similar problem to what we just did, except now instead of talking about boys and girls, we're talking about a dominant phenotype and a recessive phenotype. So we would need to know our cross. So I'm going to tell you that for this question, this is going to be the parents that we're actually looking at. So with this, there are two orders this could happen in. We could get the dominant one first, and then we could get the recessive one second. Or we could get the recessive one first, and we could get the dominant one second. So first off, what we need to do is we need to figure out the individual probability of each one of these ways that this event could happen. So if we do that, if we draw the Punnett square for this cross, I'm just going to put it right down here in the middle. Here would be my Punnett square when I cross two heterozygous parents. So once we have that in front of us, it's very easy to figure out these individual probabilities. So when I have the first child or the first offspring, the chance that it's going to look dominant, notice that we've got 3 boxes here, 3 out of 4, that do look dominant. So that would be the probability for that. That second one, the probability that it's going to look recessive is just the bottom box right here. So that's going to be 1/4. So if we want to know the probability of this way, we multiply them together and we're going to get 3/16. If we come over here and we figure out the probability of this order, the probability that that first child or first offspring is going to look recessive is going to be 1/4. And then the probability that the second one is going to look dominant is going to be 3/4. So we take them and again, we multiply them together. And then since it is the OR rule, we're going to add them. So I've got 3/16 plus 3/16, which is going to be equal to 6/16. And then we can reduce that down. It would reduce down to 3/8. So 3/8 is going to be the final answer on this particular one. Now, one thing that I do want to point out here is notice that with this question, it is implying that this is in any order. So you might see that little phrase, in any order, written in the actual question. If the question was to say in that specific order, if it's just in a specific order, there's only one way that that could happen. So for a specific order question, then we're really just using the multiplication rule. But if we have in any order, so there's multiple orders it could happen in, then we need to use the addition rule.